Assalamualaikum warahmatullahi wabarakatuh for Dr. Izwan and Dr. Nofrizal. Today, we will present about our hydraulic lift project that we have name given Automation Float System. Okay, my name is Nur Atika binti Habib and this is my team member Muhammad Afif, Muhammad Loman Hakim and Siti Nordini, and we are from group 2 and we will present about this project. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atkan Habib and my mental number is CN220392. Today I will present about the introduction of this project. Automation Float System is the name that we have given to this hydraulic lift project. The project had an 8 centimeter length and was created from recycled materials such as cartons. A hydraulic lift is a mechanical device designed to evaluate or lower heavy loads using the principle of hydraulic fluid dynamics. The project was created to accommodate and see how much weight this prototype is capable of accommodating. Therefore, the force of strength on this prototype is very important to accommodate its weight. We have used the main component, which is the string, as a component that cope with the load and which release the pressure. Okay, next is the problem statement. We have had problems with the amount of pressure applied to the string used for this project. Previously, we used two sides of the same string. It is likely that the pressure is released the same when using two identical strings. As a result, we corrected the problem by acquiring two different size strings. This is so that the pressure that emits and who receive will be different. Okay, next I will talk about the objective of this project. First, we are able to learn more about hydraulic lift and understand them better. Second is this project allow us to learn about Pascal law and how to apply it. And lastly is capable of distinguish between the application of Pascal law and other law.
Assalamualaikum. My name is Siti Nordini binti Samsul. So I will continue for my part, which is literature review. First, I find a stabilized finite element method for analysis of incompressible viscous flows using a finite volume formulation. So, in objective, overcome stability and accuracy issues in incompressible viscous flow simulations. Methodology hybrid approach integrating finite element and finite volume techniques in advancement, enhanced stability and accuracy addressing spurious oscillation and numerical artifacts. In contribution, notable improvement in computational modeling of complex fluid flows and impact is provides a foundation for more accurate predictions in engineering and scientific simulations. So for second, it's a new finite element formulation for computational fluid dynamics. In objective, we can see developing a robust finite element methodology. In methodology, which is generalized streamline operator integration, advancement, revolutioning fluid dynamics simulations, contribution foundation for future research, and lastly, impact pioneering advancement in fluid dynamics. So, number third is finite element methods for flow problems, which is for objective, comprehensive understanding of finite element methodologies. In methodology, theoretical frameworks and practical implementations. In advancement, it's insights into efficiency, limitation, and nuances. In contribution, similar resource and catalyst for future research, or we can say that finite element methods for flow problems. In impact, valuable reference for a wide spectrum of flow problems. So number four, I can find as a hydraulic design of open channel flow measurement structures. So which is for objective, we can see position in open channel flow measurement structures. In methodology, we can see as a robust integration of theory, empirical data, and practical analysis, advancement, invaluable insights, and guidelines for hydraulic design. In contribution, cornerstone resource in hydraulic engineering, impact, indispensable assets for enhancing flow measurement accuracy. And lastly, for literature review, I can say that a design of a pressure regulating valve of hydraulic leaks uh, in objective, specialized pressure regulation in hydraulic lifts. So in methodology, comprehensive blend of theory, engineering approach, and validation. So in advancement, effective design, ensuring precise pressure control. In contribution, fundamental reference for hydraulic system optimization. And lastly, impact, essential resources for practical hydraulic system design. So that's all from me.
Assalamualaikum. My name is Muhammad Luqman Hakim, and today I'm gonna present about the methodology. So by combining a cube base with a syringe as the top base, we can create an interesting and visually appealing design for our fluid mechanics prototype. You see, the reason why we choose the cube because the cube provides a stable structure and the syringe, following the Pascal laws, serves as the mechanism for fluid pressure transmission, allowing us to lift a load with hydraulic principles. Reinforce the connection between the syringe and the tube by adding additional cardboard pieces around the attachment point. This helps to distribute the force evenly. So for the designing, we make a four type of view. First is top view, front view, side view, and also the 3D view. So we choose a part or assembly that is placed on a drawing sheet is represented by a 2D drawing view. An illustration view depicts an object shape as seen from a variety of common angles including the front, top, side, and so forth. So these are the materials and tools that we are using for conducting our project. First, we have the glue gun. The glue gun is to glue the parts of our projects. And second is the cardboard box. Cardboard box is used to be our base of project, and syringe is used as a fluid mechanism. And lastly is the tube that are used for the water to flow from the tube. We are also using the scissor to cut our cardboard box, and we also use the pen to make a drawing for our design. And for the glue stick are used for our glue gun, and lastly the ruler for us to make a dimension and our calculation for the project. For the fabrication process, first the hydraulic lifter prototype was scraped by taking measurement for the foundation and stands based on a pre-designed dimension. Second, we cut the cardboard pieces into the proper form using scissors and drill a hole in the middle of its bottom for the tube to pass through. The trim components are assembled according to the necessary dimensions and assembled based on the blueprint that we have developed. And fourthly, we connected the piece using a hot glue gun, opting for its strength and ability to provide a clean finishing for the final assembly. After that, the syringe was attached inside the cube, and to establish a suitable platform for our project, we glue the cardboard top base into the syringe handle, and lastly, we add water to the syringe and tube. The tube functions as the pipe, and the syringe acts as the hydraulic for transferring the medium between the hydraulics. So this is the final product of our project of hydraulic lifts, and we have concluded all four sort of view one slide, which include the corner view, the side view, the top view, and also the bottom view.
For the calculation, we are using the Pascal law. The formula for the Pascal law is pressure equal to force per area. The mass of the load that we got is 0.600 kilogram and the diameter of the string is 0.10 meter. First, we must find the area. Using this formula, pi d squared per 4 and the diameter of the string we put in the formula and we got 7.85 meter square. And then we must find the force. Force is equal m mg, the mass of the load that we got, and multiple 9.81 and we got 5.886 newton. And then after we got the area and the force, we put in the formula Pascal law, and then we got the answer. And we got the answer 749.8 Newton.
Okay, next, let's move to result and discussion. So in our fluid mechanic lift load prototype project, we built a device that can lift objects using fluid pressure. We use Pascal law, which says that when you push on a confined fluid, the pressure spread throughout the fluid. We made a system with syringe to amplify the lifting force. By having one syringe push a smaller one, we could lift heavier object. We choose material carefully, making sure everything was leak-proof and stable. Our prototype could lift more than 50 grams, and we test it to see how much it could handle before breaking or becoming unstable. We measure the input force and compare it to the weight lifted, checking how efficient our system was. We learned that pressure spread evenly, but there were limits and challenges like possible leaks or box strength. We compare our actual result. We we compare our actual result with what we expected, finding error like friction or air bubble in the fluid. So in the end, we show that Pascal law can be used to make a simple and effective lifting device. We discuss ways to make it better and adapt it for different uses. This project opened up opportunities for more research and improvements in design and material. Okay, next, let's proceed to improvement. For improvement of our project, we changed one syringe to a smaller size. The purpose of changing the syringe is to reduce the force that we will use later. This is because the area of the syringe is smaller. Previously, we used a 20 ml syringe. For improvement, we changed the syringe to 5 ml. As for the tube, we shortened the tube from 17 cm to 12 cm. This will reduce the bubbles in the tube and our prototype will work more effectively. Thank you.
Okay, for the conclusion is we may conclude that the same pressure will result in the prototype being unable to carry the load well. We are using concept Pascal law for this project. Pascal law is a fluid mechanic principle proposed by Blaise Pascal that asserts that a change in pressure at any point. As a result, we carry out this project in accordance with Pascal law. Finally, this project that has taught us as a group how to work together to complete this assignment successfully. Okay, that's all from us for this project. Thank you.